Howdy! It's Friday, the 14th of October, and today was supposed to be my last full day of working, but it rained really hard all morning, so I'm not sure how much I'm going to get done. As you can see, our little moat is filled in again with lots of little water, and hopefully we'll stop here pretty. Oh, there's some clearing right there. Maybe it'll stop raining. But I'm getting oh so close at getting to a stopping point in this, but I thought I would take some time and do some science with you. Come in here, I'm going to show you something. Before making these videos, I never really realized how much, from any one moment to the next, how much science one does. Now, keep something in mind that science is a verb. It's something that you do. It's not a noun. Well, it is technically a noun, I guess, but it's really something that you do. It's a process. It's not like studying Kepler. And okay, well, he did science, and we study about him, and that's kind of really history. So what science really is, it's a process of solving problems, right? And instead of, I'm going to forego the tour as usual and just get right to it. I'm trying to figure out a way to latch these windows. See, right now I've got these windows in here and I'm using shims to kind of hold them, but I can't leave them like that. I've got to latch them, put little handles on them and stuff. So here I got these kind of tiny little handles here, and they work pretty good. They're kind of cool. So here's the thing. I wanted to do something really, really fast and simple and cheap, because there's 22 windows in this place. So I rooted through, Home Depot, and I found these little magnets. Can I see one there? Probably seen these before, and they are for cabinets and stuff. So the idea is that this magnet hits the plate and it stops. Okay, so here's the thing. This is something that I observed while doing this, is that I put this magnet in and I was like, it's okay. And I noticed that, man, any kind of wind in here is gonna just knock that out. And so I put another one over here, and it's even worse. It's like, man, you barely touched that thing. And so I thought, what's going on? Is it just a bad idea? Is it not going to work? But then I put a couple more in, just kind of playing around. Different window. Same basic kind of magnet. That one's still kind of weak. It's a little better though. This one's really good. It's really strong. I mean, you can hit this thing and it's staying. That's kind of the way I wanted it. Like that. So what is special about this that these other things don't have? Because I want them all like this. I want them to stop like that. And this is where science comes in, because you observe something. You observe that that magnet is not the same as these, or the mechanism, or something. So I make the observation, I state the problem. How do I make this setup work better, work more like that one, less like these? So there's a bunch of variables involved here. First of all, the variable that I want to measure is called the dependent variable. It depends on something else. Something else is causing this. And I'm going to call this stickiness? The sticking power. How's that? The sticking power. Something is causing the sticking power on that window over there to work better than this one. So now I got to list all of the possible variables. And you can make a really long list. One thing is that this little magnet here is a single magnet. I don't know if you can see that. This one is a double. There's actually two magnets there, because they ran out of those at the store. So I got a couple of these. The size of the magnet. What are some other variables that you can come up with here? Maybe you could stop filming or just kind of hum for a little bit while you decide how to set this whole thing up, because you all are expert scientists, of course. You know how to go through the process: observation, hypothesis. Oh, look, screws. See that right there? Always look for screws. All right, so take some time while I just kind of walk around, looking at how wet it is. Cute little window, right? Okay, we're back. So, variables on what causes one to stick and not to stick. Okay, so size of magnet, obviously. You got a little magnet, big magnet. That might cause it. How about the distance? So this is a big lever, right? You got a hinge, it levers out. What about where this is along this line? If it's really close over here, really far over there. That was one thing I kind of played with. What about moisture? This guy's like soaking wet from the rain. Maybe that affects it. Maybe that's it. Maybe, well, that just works really well. Maybe it's the fact that maybe not all of these are connecting with this. Maybe this is not in the right place. I just killed the bug. So there's lots of these possible things. What I first ran with was where it was along this line. So at first I thought, well, maybe I need to move it this way. And I thought, well, maybe I need to move it this way. Because one difference here, and this is kind of really jumping into the experiment, the hypothesis. The hypothesis is what variable causes the dependent variable? What variable causes the power of the sticking power? And the first variable I went with and experimented with was this distance here. So this is a lot farther back. But this is closer here than this one is. Does that make sense? This distance here. So this would be like something that I measured. Measure this distance and see, you know. But the question is, how do I measure the dependent variable? How do I measure sticking power? Because this right here, just tapping on it, it's hard to collect data on that. How much force. So I need an instrument that tells me how much force I'm applying to this. Because I can play around with this all day long, but if it's just a matter of just feeling it, you can kind of tell, but it's not real definitive. I don't know when I'm on the right track. When I get on the right track, my data is going to start to change. The force is going to start to change. Now, if I had some of my science tools, I'd use something called a Newton meter, which measures force. It's kind of like a spring box, right? And you pull with it, and it tells you how many newtons of force. It's a real thing, a Newton. And it tells you how much force that you're applying to something. And I don't have that. I did find this bungee cord. And so what I thought is I would get this little bungee cord and kind of hook it on there and like get a certain point of measurement and pull, and you see there's a give before it breaks. And I could measure how much give there is. Hello, look at that. That's amazing. Woo! Hello. Okay, so I can measure that give right there. And that was a lot of give right there. So and I'm going to try over here on one of my wimpy windows. Well, I got another one over here I just freshly put in. Now I'm not actually measuring right now. I'm just kind of showing you what I have to measure. I have to hold this camera. So I point, I pull, and that's pretty good too. And that's real good. That's pretty good pull. So what I'm going to need to do here is hook this up, mark this, get a ruler, and see how much distance is pulled on my bungee, because it's kind of like a Newton meter. It's you know, fairly reliable. It's better than just pushing. It gives me some data to look at. All right, so I'm going to do that, and I'll come back with you in a second.